Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dokpo Jr., the math tutor and mathematics instructor at the University of Liberia. In my today's lesson, I'm going to discuss differential equations, and particularly I will look at a problem under variable separable, but using trigonometric substitution method. So let's see how trigonometric substitution method works for a variable separable problem. So we said in previous lessons that when you have a differential equation and it's possible that you separate the variables, that is, if you have an equation in x and y, so if it is possible that you can allow all of the expressions with x to be one side of the equation and the expressions with y on one side of the equation, then it means that you can find its general solution by means of variable separable method by integrating both sides of the equation after the variables have been separated. So what if you have a differential equation that is somehow challenging to separate the variables in that form? So you can also employ the trigonometric substitution method. Trig substitution method to be able to solve that problem. So let's get started. Now we have this differential equation, xy x dx plus y dy, or over x dy minus y dx equals, so we can separate the root because we know that the root of a over b is equal to the root of a divided by the root of b. So we can take the numerator separately, but we can factor out this x squared and this, let's say this negative right here. We can just ensure that this x squared and y squared is positive. So if we factor out negative, we're going to have this expression, all divided by the root of x squared plus y squared. Now we know that the equation of a cycle will center at its origin. If you have a cycle like this, let's say we have a cycle. Okay, so let's say we have a cycle and the center is at its origin. We can draw a line that we call the radius from the center to the circumference of the cycle. So we assume that this was point O, this was point A. Then we drop this line, forming right angle degree with O and B. So we can name this side some x since it's on the x-axis. We can name this side some y since it's on the y-axis. We can call this angle theta, and we call this some arrow since that's the radius. Okay, now what we need to do is that we need to substitute x, y, dx, dy, the root of x squared plus y squared, and bring in some trigonometric functions in angle theta. So our new function now will be arrow with respect to the variable in a function called theta. So we want to get rid of all of these and bring in some trigonometric functions. So how do we do it? Let's start with x. If we want to substitute x, we know that in order to get this x, we need to pair x with arrow. So in order to pair x with arrow, we need a trigonometric function that defines x and arrow. So we know cos of angle theta is equal to the adjacent side, which is x, divided by the hypotenuse, which is arrow. So this is x all over arrow. So we can express this over one since we want to solve for x. We have x to be arrow cos of theta. Now we've gotten x. But that's not all. We also need the x. So we differentiate this x. The x equals, we use the product rule. We hold arrow and differentiate cos. We get negative sine of theta plus we hold cos of theta and differentiate r, we get 1. But since r is a new function, we attach the r all over the theta. So the x now becomes cos of theta, the r all over the theta, minus r sine of theta. So this is our new, this is our dx. Then we move to the next one. We say let's find y. So to find y also, we know that we need to pair y and r. So we can use a trigonometric function called sine of theta. We know that sine of theta is opposite side, which is y, or over hypotenuse, which is r. Dividing both sides, let's say expressing this 1 over 1 and cross multiplying, we're going to have r sine of theta. So since we've gotten now our y, what we need is to get our dy by just differentiating this y. So we get dy now equals, we hold r and differentiate sine, we get cos of sine of theta, plus we hold sine of theta, and we differentiate r, we just get 1. So we attach the r over the theta since we have differentiated r, because r is a function. So we've gotten dy and we've gotten y. So the next thing we also need is, we need this root of x squared y squared. So what do we know? We know that the equation of a cycle with center at its origin is x squared plus y squared equals to r squared. So wherever we see this expression, we want to bring in r squared. So if we take the square root on both sides, we're going to have x squared plus y squared. So the square root now, we just cancel these 2, you've left with r. So r now will be equal to this. So let's go now to the problem. So we go to the problem. We have x, there is it, x. So this x now is r cos of theta plus y. Let's say the x now is cos of theta, the r all over the theta, minus r sine of theta. So this is x dx, this one, plus y dy. So what is y? This is y, r sine of theta times r cos of theta plus sine of theta, the r all over the theta, divided by x. X is r cos of theta. Dy is r cos of theta plus sine of theta, the r all over the theta, minus y, r sine of theta. And then what is dx? Dx is cos of theta, the r all over the theta, minus r sine of theta. So you have to be very careful before you miss some signs and everything. So this one now is the root of a square minus, so this whole thing now is just our r square, divided by this entire root is just r. So you see, it's very easy. It's very, very easy. Okay, so we can simplify the numerator. So r cos of theta times r cos of theta, let's say times cos of theta is just r cos square theta, the r all over the theta, minus r times r is r square sine of theta cos of theta. Finish with the first one, plus r times r is r square sine of theta cos of theta, and then plus r sine of theta, and sine of theta is r square sine square theta so it's r square sine square theta d r all over d theta equals the root of a square minus r square all over r divided by, okay, so we just want to bring this thing down. It would just be a square minus r square all divided by r. But let's come on this side as well. So we have r cos of theta times r cos of theta is r square cos square theta, and then r cos of theta times sine is now r sine of theta cos of theta, and then next this is dr over d theta minus this, and this is r sine of theta cos of theta dr all over d theta, and then this time this negative times negative is positive, r square sine square theta. So what do we observe? The middle terms here. So this cancel this. What's about this? This cancel this. So you see we are gradually ending the problem. So the problem now is getting more simple and simple and simpler and simpler and simpler. So the first one and the last one, you have r. Okay, so this should be r and r. It gives us r cos of theta, and then the last one should be r and this. So this is just r not square. It's r sine of theta times sine of theta. It's just sine square theta r. So now we group the first and the last. In fact, that's the only terms there. So r and r, we can factor it out. So we bring r outside, and then we say cos square theta plus sine square theta times the r all over d theta. So we can also factor out the r over d theta divided by r square. Likewise with this, and this. So we can factor out r square. So we're left with cos square theta plus sine square theta all equals to the root of a square minus r square divided by r. So we know that, note, from the Pythagorean identity, cos square theta plus sine square theta is equals to 1. So right between here, we're going to have r times 1. In fact, this r can cancel 1 from here. So it will just be the r over the theta divided by, so this one is just 1 equals the root of a square minus r square all over. Sorry. So we have r here as well over r. Now when the denominators of a fractions are let's say the denominators of two equations are the same, they just go out. Let's prove it. We have x equals to 5 over 2 over 2, for example. So you can just say this cancel this, x is equals to 5. Or if you like, go the long way. So this is x over 2, 5 over 2. We cross multiply. This is 2x is equals to 10. We divide this out by 2. So 10 divided by 2 is 5. So when the denominators are the same, they go out. No waste of time. So what are we left with? We are left with the r over the theta equals to the root of a square minus r square. So we can cross multiply now. So we're just going to have the r equals to the root of a square minus r square d theta. Because this is d theta, we need only theta in this expression. We don't need r. So we can divide both sides by a square minus r square over the root of a square minus r square. So it can remain on this side. So this and this cancel. So we're now left with the arrow all over the root of a square minus arrow square equals to the theta. So we can now integrate both sides now since the variables have been separated. So this gives us sine inverse of arrow all over a equals theta plus some arbitrary constant c. So what is arrow? Arrow was just the root of x squared plus y squared all over a. That was our arrow. Equals, what is theta? So we can come back here and solve for theta. We know that tangent of theta is equal to the opposite, which is y, all over the adjacent, which is x. So to solve for this angle, we can take the inverse on both sides. Tangent inverse on both sides. So tangent inverse of tangent of theta is just equals to theta. And we'll take tangent inverse on both sides. So this would just be tangent inverse of y over x. So this is now equals to tangent inverse of y over x plus some arbitrary constant c. So this is our general solution of the differential equation. So if you want to further maybe rewrite it, you can take a sine inverse on both sides so that this whole thing can just go out. Let's say this sine can lost, then you will be left with what is in here. Or if you want to deal with this tangent, you can send this c across and take tangent on both sides so that this tangent inverse can disappear. But whatever way that your instructor asks you to rewrite your final answer, you can express your answer in that form. So this is how we solve first order, let's say a first order linear differential equation using substitution, the trigonometric substitution method on a variable separable. So thanks all so much for watching. See you in our next lecture. Yeah, sure. Thank you. Please don't forget to subscribe, like, and share the videos.